Welcome to the Cortex Learning Blog. This is tutorial 4 of 9 relating to CESA 2 input basics. The next series of tutorials is related to creating a model. This is the first part. What we will concentrate on now is to input the first element. Before creating the first element, what we really should be doing is getting a drawing of the piping system that we're going to be modeling. We should represent the geometry of the piping system, the wall thicknesses, the diameters, materials, temperature, pressure, and the fluid characteristics. We then turn this into an abstract model in CESA 2. With node numbers and various elements like rigid elements and anchors and so on that define the boundary conditions. For your convenience, we've produced a PDF document that has this diagram for you, and you should probably download that and keep it handy while we're going through this tutorial. This is the first screen that you're confronted with when CESA 2 opens in the new model. It presents you with a suggestion of node numbering. You can change these increments in the configuration file. The top corner here, top left-hand corner, details the elements, the data associated with this one particular element, and we can associated forces, moments, all that sort of stuff, and also present bends, displacements, restraints, and so on. Okay, well, if you look at the diagram, the first thing we want to do is to put in the length of the first element. So let's create it as 400 millimeters, and you'll notice here that CESA 2 creates a little stick that's 400 millimeters long, very thin, because it doesn't yet know what the diameter or the wall thickness of this element are. So moving to the diameter field, we type in 10. Now this is for 10 inch, and notice that CESA 2 has created a 273 millimeter diameter element for this. The reason is if you press F1 in this field, you'll pop up this help screen. If you type in any of these numbers, it will convert those to millimeters, actual millimeters. Likewise, if we go to the wall thickness field and click F1, we get a help screen that shows us that if we type in S, it will substitute the actual wall thickness. XS for extra strong, double extra strong, double XS for extra strong, double extra strong. So we've converted it to actual millimeters here. Moving on to the material, we have a pull down menu here. You can see that there are multiple materials available in CESA 2, and you can add to these in the configuration file as well. As soon as you select a material, it will fill in Young's modulus, allowable stresses, densities, Poisson's ratio, and so on. The default code this time is B31.3. You can change that in the configuration, and once you do that, it will look up the appropriate allowable stress. From our diagram, we know that the corrosion allowance is 3 millimeters, so we simply type that in. Fluid density is another shortcut that CESA 2 offers. If you click F1 again on that field, you'll see the units, and you'll see that if you type in for a number followed by SG, then it is converted to the units that you've elected for this particular model. So let's type in 0.72 SG, which is what is on our drawing, and you'll see that it converts it to the appropriate units. Now, moving on to temperatures. We know that the temperature here is 330 degrees C. And notice when I hover the cursor over any field, it comes up with the units that are appropriate. So for pressures, temperatures are degrees C, pressures are kPa in this case, and we have 1700 kPa. Notice when I've done that the hot allowable stress, SH1, has changed because of the allowable stress has changed. SH2 hasn't changed because we actually haven't put in a temperature 2 yet. We can move down to insulation thicknesses. We have 65 millimeters, and we're told it's calcium silicate. CESA 2 has built-in database of different materials, so let's just select calcium silicate in this case, and you'll see that the density is filled in automatically for us. Okay, that's nearly the first element completed. Let's just turn on node numbers here for a second so we can see what we're doing. We know that there's a restraint at node number 10, and we know it's an anchor. So let's page down here, and we see that there's a whole lot of different sorts of anchors. We can look at the applications guide to find out how these all work, but we'll just select the anchor. Now, this basically completes the first element. There's a fair bit of work involved in doing that, but once we've done that, most of the data that we've inserted will actually be carried forward into the next element. In fact, all of the stuff in this bottom left-hand corner of the spreadsheet will be carried forward to the next element. Okay, well, we'll move on to the second element in the next session.